Hi, this is my four-stroke engine project, which was originally a high school math project. We basically have to graph some object in DESMOS. So I sort of took it a step further by animating it, by adding a variable a here. And it's a combustion engine that has all four cycles of a four-stroke engine. As you can see, the variable ranges from 0 to 4 pi. So each pi represents one phase of one stroke of a four-stroke engine. So as you can see, there's an intake, compression, combustion, and then finally the exhaust. So this is how I started. I started with the crankshaft of this engine, and as you can see, it's just the counterweight rotating around the origin. And I achieved that by basically using some trigonometry to make these several functions rotate. But then comes the connecting rod. And this is probably the most fun equation I had to come up with. So it's a rod that transforms circular motion to, well, vertical motion, as you can see here. But admittedly, this is actually not the most accurate model of a real connecting rod. As you can slightly see, the length of the rod actually doesn't stay constant throughout the entire cycle, which is something you don't really want in your car. So what happened here is I wanted the piston to follow a sine function as it moves, so I can easily translate it up by using the variable a and adding a cosine in front, for example. But this is actually not how a real-life engine works. So as you can see, as the crankshaft rotates 90 degrees, in my model, this piston will fall down exactly halfway. However, in a real-life car, it will actually fall more than halfway, since not only does it decrease this distance, it also pulls it to the side. So over this 90 degree, a real piston will actually move down a bit more than what I have here. But that's just something I had to do to make this animation a bit simpler. And as you can see, it's already lagging a bit, and that's before I add some camshafts, which you'll see later. So after this, I modeled the entire cylinder block, which is actually one of the easier steps, as all of them are not moving, and plus a spark plug, which I must say looks pretty accurate. And then comes probably my favorite part of this engine, which is the camshafts and the valves. And get ready for some lag as I torture DESMOS. So what happens here is I use this rotating ellipse to push down on this valve, which moves in a sinusoidal manner. And this works because, I watched this video, I mean, who hasn't? And basically it shows that in order for ellipse to roll on a road smoothly, the road has to be basically a sine curve or a cosine curve. And I took that and applied it here. And it works pretty well. It roughly follows the shape of this ellipse. And same on the other side as well. So I actually modeled this over a year ago, but I wanted to make a YouTube series on all of the stuff that I modeled in DESMOS, because I've been doing some new stuff. So stay tuned for the next video, where I show my model of a Wankel engine, or a rotary engine. Bye!